Okay, so I wanted to make a clarification of the select event that I had picked out of Sternglass's book. I think it was the most important, where he discussed the orbit of the electron around the proton, and that Born statistical case where the nucleus captures, where the proton actually captures the electron, because that's a unique thing. Because the electron, it has to actually not just make it around around some points around the proton, it has to make it around every point that it could be in space around the proton before the nucleus absorbs it. So each time an electron that's spinning around the nucleus in all space-time points that it could possibly do so, once it completes every point of space-time around it that it can, and that's when that case occurs. So each cycle of it being in every space-time position around the proton, once completed, captures an electron. And it does that for 16 trillion years. And after 16 trillion years passes, then the cosmos differentiates from a monopolarity to bipolarity or dual polarity. And that's what creates that event. So that the cosmos emerges, if you will, out of itself and back into itself and out of itself in cycles of 16 trillion years that Sternglass reports in his text. I'm clarifying his reasoning because I went further than he did in actually clarifying that in that case that he was mentioning of the Born statistic. Max Born of Germany was one of the greatest physicists of the 20th century, because he's the one that came along for quantum mechanics, and he said, but each quantum field that's configured has a statistics that are applied to where the electron can be found in any quantum field. But he started with the most simple quantum field that could be configured, and that was, of course, where Niels Bohr began. But Born, he brought more clarity to it because he began looking at all the configurations of the electron field where the electron was in the place where it would be only in 1% of the cases, where it would be in 98% of the cases, where it would be in 97% of the cases. And he worked through every statistic that could apply to Niels Bohr's hydrogen atom. So he allowed quantum mechanics really to begin as a calculating science. And so that's where he added a great deal of knowledge and information. But Sternglass, what's important about him, and I'm sure the physicists are just like, oh my God, don't say that name anymore. I'm going to have to give him a new name. I'm going to call him Arrowhead from now on. Dr. Arrowhead. Dr. Arrowhead, he actually he went beyond that. He went beyond what Max Born said, because he said that case of the proton with the electron moving around it, and I wonder if Steve Weinberg agrees with me about this, that when the electron covers each possible space point that it could be in, because there's only a certain number of possible ones. There's not an infinite number. If you take a proton and you put it in a field, say you put it in a 9 micron field, and you configure that, you say, here I'm going to measure for the proton. And then you ask, I almost called it Max, Robert Wald, if he said that, and he makes that field with his instrument there, and starts from that proton, then he works out each point where the electron can be in relation to the position of the proton. Now, Heisenberg would already say, no, wait a minute, Jeff. wait a minute, because we don't even know where that proton is. We only know where it likely is. But no, because you work out all the places where it can be, and then you work from each of those relative positions to where the electron can be relative to it. And then you discover, as Sternglass did, that it must be in just this number of positions, say 10 positions for the proton and 9 million for the electron. So every time it's in one of the 10 positions and it goes through the 9 million positions that the electron can be, then the proton absorbs the electron. But the proton can't absorb an infinite number of electrons. It can only absorb so many electrons, say 700 billion. And after it absorbs 700 billion, then it creates the neutron. So it can't just do anything. It has to do relative to. For a proton to be in a particular space, say a 9 micron by 9 micron square, it can only be in 10 positions. And so what Sternglass was reporting there in his text was that that case produces the neutron. So he came up with a theory of how the neutron is produced. But then when we go to Dirac and we see that what he was applying in micro applies to the cosmos in macro, then we could see that when the large scale atom that is the whole cosmos goes through all the positions that the electron can be in and absorbs all the electrons in the proton that can possibly be, then the whole universe spins out the fabric of the entire periodic table, both of the elements and of the different galaxies that can be created. There's only as many different galaxies as there are divisions in the periodic table. And there are 4, if I remember correctly. There are 4 different, let me make sure I put up 4 fingers, because last time I said 4, but I was only showing 3 fingers. But there's only 4 different divisions in the periodic table, and those correspond to the types of galaxies that there can be of stars, and the types of stars there can be. So I'm just trying to clarify. Sternglass was describing a triple neutron star: proton, electron, positron, and all the positions that they could be in. But Steve Weinberg and I may or may not agree. Stephen Hawking and I may or may not agree. Julian Barbauer and I may or may not agree. Roger Penrose and I may or may not agree. The author of The Physics of Immortality, Frank Tipler, and I may or may not agree that 16 trillion years of that motion, since it's relativistic motion, can be 300 million years, or 3 million years, or 1 million years, because it's relativistic motion. See, the energetic motion of the two particles, one around the other, in shapes that Sternglass went way beyond anything I could think. Since it's relativistic motion, that what he calculated as 16 trillion years, and that would be the age of the universe at present. 16 trillion years plus the 13 billion years that we presently have, but it's older than that because it's existed forever. That's what Sternglass was saying. It's existed, its ages forever. But how do you translate that like into years? It's always existed, is the point, but that motion that can be detected with our instruments up to the first 3 minutes. See, Steven Weinberg, he's not being arrogant when he writes a book called The First 3 Minutes. Neither was Ernest J. Sternglass being arrogant when he said the 16 trillion years prior to the first 3 minutes. So you could retitle Arrowhead's text, and you could say Arrowhead said 16 trillion years in 3 minutes.